Hello, in this video let us discuss minors, cofactors, and transpose of matrices. Let us consider the following 2 by 2 matrix. And let's say the requirement here is to find the minor of this matrix. So minors of this matrix A is, of course, we have another 2 by 2 matrix. Now, the concept is this. To determine the minor, you have to find the determinant of the matrix after removing row I and column J. For example, this term right here, this is the term in the first row, first column. So that's element A11. That's equal to 3. It means the element in the first row, first column. Now, this has a corresponding minor, and we will call it M11. And according to the definition, we have to remove row I and column J. So, the element is in the first row. Let's block the first row like this. And then this is also in the first column. So let's block the first column. And whatever left inside, we should get the determinant. In this case, since this is only a 2 by 2 matrix, there's only one element remaining, which is 7. So safe to say that's the determinant. And we will replace by 7. Instead of 3, we will replace it by 7. Okay? That's the minor of this element. Next. How about this element over here? This element is in the second row, first column. So we can say that that element is A21. And that is equal to 2. The element in the second row, first column. And the corresponding minor, M21, is equal to, so let's block the second row. And let's block the first column. The remaining value is 5. So we will replace this by 5. Right here. That's how it works. Next. This term right here, that's the element in the first row, second column, equals 5. And the corresponding minor, the minor in the first row, second column, is equal to, let's block this column. Let's block this row. We're left with 2. So we will replace 5 with 2. So replace 5 with 2. And then the remaining, the element in the second row, second column is 7. Right here. And if we block the second column and the second row, we're left with 3. So the corresponding minor is 3. So we will write 3 here. And that's our minor. Next, let us try to find the cofactors. So cofactors of matrix A. And the cofactors of matrix A is similar to its minors, except that there's some variation on the signs. Okay? So there's a formula for cofactor. The cofactor of an element, so let's say we have an element A in the first row, rather ith row, and jth column. The cofactor is Cij, and this is equal to -1 raised to I plus j, and then times the corresponding minor, Mij. For example, this term right here, this is the element in the first row, first column. So the cofactor in the first row, first column, it means I is equal to 1, j is equal to 1. This is equal to -1 raised to 1 plus 1. I and j are both 1 times the minor, that is 7. Okay? And as we know, 1 plus 1 is equal to 2, -1 squared times 7. And -1 squared is +1. If you raise it to an even number, it should be positive. So C11 is equal to, so since this is +1 times 7, C11 is equal to 7. Okay? Therefore, we have 7 right here. Okay? Next, let's try to find the cofactor of the element in the second row, first column. Okay, so C21. The formula, let us apply negative 1 raised to I is equal to 2 plus j is equal to 1. And then times the minor is 5. Let's proceed. We have negative 1 raised to 2 plus 1, that's 3 times 5. And negative 1 raised to 3, we have a negative base raised to an odd number or odd power. So that stays negative 1 times 5. Therefore, C 1 is equal to negative 5. Therefore, we have negative 5 right here. Next, let's try to find the cofactor in the first row, second column. So first row, second column is right here. And we have negative 1 following the formula raised to I plus j. I is 1, j is 2. So 1 plus 2 times the corresponding minor, which is 2. Therefore, we have negative 1. 1 plus 2 is 3 times 2. Negative 1 cubed is negative 1. And negative 1 times 2 is negative 2. So C12 is equal to negative 2. So we have negative 2 right here. And finally, let's solve for C22. So let's find the cofactor in the second row, second column. Following the formula, negative 1 raised to I plus j, so 2 plus 2, times the corresponding minor, which is 3. Negative 1, 2 plus 2 is equal to 4, times 3. Negative 1 raised to 4, 4 is an even number, so it becomes positive. And 1 times 3 is 3. So the cofactor is 3. Again, the cofactor in the second row, second column is 3. Therefore, our cofactors is complete. Now, we have an easier approach to find the cofactors because following this formula is kind of time consuming, and I will show you the rule of signs for a 2 by 2 matrix cofactors. Let's say, let us solve again for the cofactors. So, this is the 2 by 2 matrix cofactors sign convention. It means all the elements inside, we have to apply these signs. So, for example, for this value right here, 7, that's positive. So, just write positive. And then, for this element, this is negative. This one is also negative, and this is positive. And if you simplify, we'll end up with 7, negative 5, negative 2, positive 3. And now, this is the cofactor of matrix A. And upon using this, as you can see, it saved us a lot of time instead of following the formula. Now let us try this one. Let us try to solve for the minors and cofactors. Let's begin with the minors. The minors of matrix B is, you know the concept. Okay, for the element in the first row, first column, let's block the first row and the first column. And we're left with 2. So let's write 2 right here. And then for the element in the second row, first column, like that, we're left with negative 1. Next, first row, second column, we have 3. And lastly, for the second row, second column, we're left with 4. And that's your minors. All right. Now, let's go to cofactors. So the cofactors of matrix B, first let's copy the minors. So this tells you that in order to find the cofactors, you need to find minors first. Let's copy. All right. Applying the 2 by 2 matrix cofactor signs, we have plus here, we have minus here, and then minus here, and then plus right here. That's it. Which means the cofactors, we have 2, positive 1, negative 3, positive 4. Now let's try some 3 by 3 matrices. Suppose we have this 3 by 3 matrix that I'm going to write. Now, let us try to find the minors of this matrix. Minors of matrix C. The concept is still the same. In order to find the minors of each element, we have to determine or we have to solve for the determinant of the matrix after removing row I and column J. So, let's begin with this element. This is the element in the first row, first column. Let's try to find the corresponding minor. First row, first column. Now, this is equal to the determinant. If we block the first row, first column, we're left with these 4 values or 4 elements. So we can assume this as a 2 by 2 matrix. So let's find the determinant of the 2 by 2 matrix. Negative 1, 2, 4, 0. That's it. Okay? So what's the determinant? Negative 1 times 0, that's 0, minus 2 times 4 is 8. Therefore, M11 is equal to negative 8. Therefore, we will write negative 8 right here. Next, let's try to find the minor in the first row, second column. So the minor in the first row, second column, look at these 4 values, 0, 5, 4, 0. Okay? So determinant of 0, 5, 4, 0. So this is equal to 0 times 0 is 0, minus 5 times 4 is 20. Therefore, M12 is negative 20. So we will write negative 20. Next, the minor in the first row, third column. So that's equal to the determinant. And let's block the first row and the third column. We have these 4 digits right here. So determinant of 0, 5, negative 1, 2 is equal to 0 times 2 is 0, minus 5 times negative 1 is negative 5. Therefore, M13 is equal to positive 5. So we have 5 here. The element in the first row, third column. And we will repeat this process for the entire elements inside the matrix C. I suggest that you must reach the point where you don't need to write whenever you're solving for determinants of 2 by 2 matrices like this. It would be better if you can calculate them in your head, unless you need the solution for an exam. But if you need faster solutions, better that you can solve this in your head. So let's try that. Let's proceed. For the element in the second row, first column, so if we block the second row and first column, we have these 4 numbers. So 2 times 0 is 0, minus 2 times 3 is 6, so that's negative 6. Right? Next, for the second row, second column, if we block them, you have the 4 numbers, 1, 5, 3, 0. So 1 times 0 is 0, minus 5 times 3 is 15. So that's negative 15. Next, second row, third column, let's block that. We're left with these 4 numbers. Okay, so 1 times 2 is 2, minus 5 times 2 is 10. So 2 minus 10 is negative 8. Next, for the element in the third row, first column, we have this 2 by 2. So 2 times 4 is 8, minus negative 1 times 3 is negative 3. So 8 minus negative 3 becomes 8 plus 3, so that's 11. And then, third row, second column, we have these 4 numbers, so or 4 elements. 1 times 4 is 4, minus 0 times 3 is 0, so that would be 4. And lastly, third row, third column, we have these 4 elements. 1 times negative 1, minus 0 times 2 is 0, so negative 1. And that's your minor. Now let us solve for the cofactors. For the cofactors, I'm going to copy all of the elements of the minors. And just like the 2 by 2 matrix, we also have sign convention for 3 by 3 matrix cofactors. So this is the rule of sign that we should follow instead of using the formula because it is lengthy to solve. Now, let's apply. Plus here, and then minus here, and then plus, and then minus, plus, minus, plus, minus, plus. Now let us simplify the elements of this cofactor C. Okay, so this is wrong. It should be C. Let me replace. So C. So the cofactors of matrix C is, this is negative 8. This would be positive 6, negative times negative. Positive 11. Positive 20. Negative 15. Negative 4. Positive 5. Positive 8. And negative 1. So this is the cofactor. Next, let's consider the following 3 by 3 matrix. Okay, let us solve for minors. So for minors, we have to block or we have to remove the necessary rows and columns. For the element in the first row, first column, let's block this. So we're left with these 4 elements. And we have to find the determinant. So negative 1 times negative 2 is positive 2. Minus 2 times 4 is 8. So negative 2, rather positive 2 minus 8, that's negative 6. Okay? Next, the element in the second row, first column, we're left with these 4 numbers. Okay? Therefore, 0 times negative 2 is 0. Minus 2 times 1, that's 2. So 0 minus 2 is negative 2. Next, the element in the third row, first column, so we have these 4 values or 4 elements. 0 times 4 is 0. Minus negative 1 times 1, that's negative 1. So 0 minus negative 1, that is positive 1. Next, the element in the first row, second column, right here. So we have these 4 values or 4 elements. Excuse me. 3 times negative 2 is negative 6. Minus 5 times 4 is 20. So negative 6 minus 20, that's negative 26. Next, the element in the second row, second column, so we have these 4 numbers. 2 times negative 2 is negative 4. Minus 5 times 1, so that's 5. Negative 4 minus 5, that's negative 9. Next, the element in the third row, second column. Okay, so we have these 4 elements. 2 times 4 is 8. Minus 3 times 1, that's 3. So 8 minus 3 is 5. Let's proceed in the first row, third column. So we have to find the determinant. 2 times 3 is 6. And then 5 times 1 is negative 5. 6 minus negative 5, that is 6 plus 5 or 11. Next, second row, third column. All right. So we have these 4 values or 4 elements. 2, 0, 5, 2. 2 times 2 is 4. Minus 5 times 0 is 0. So 4 minus 0 is 4. And finally, third row and then third column. 2 times negative 1 is negative 2. 3 times 0 is 0. Negative 2 minus 0 is negative 2. And here's your minor. Next, we will use the rule of signs and apply it in our minor to find our cofactor. So cofactors. Let's apply directly. For the element in the first row, first column, we have positive. So positive, we assume this plus positive. Let's assume this as positive 1. So positive 1 times negative 6. So that's negative 6 still. Negative 2 times negative. So it becomes positive 2. Positive 1 times positive, still positive. Negative 26 times negative, that's positive 26. Negative 9 times positive, still that's negative 9. And positive 5 times negative becomes negative 5. 11 times positive, positive 11. 4 times negative, so negative 4. Negative 2 times positive, so negative 2. That's it. That's your cofactors of matrix D. Next, let us discuss transpose. For example, we have this matrix, matrix A, wherein the elements inside are in the form A, I, J, where I stands for the row and J stands for the column. The transpose of this matrix means you will swap the positions of the rows and columns such that the elements inside is in the form of A, J, I. Okay? So this is easy. For example, we have this matrix A and the elements inside, assume this is a 2 by 2, 3, 5, 7, 2. All right? Now, the transpose of this matrix means we will swap the rows and the columns. The elements in the first row of this matrix are 3 and 7. So it becomes the element in the first column of our transpose. So 3, 7. The second row of the matrix has the elements 5, 2. It becomes the elements in the second column for the transpose matrix. Another example, let's say we have matrix B and assume this is a 3 by 3. Therefore, the transpose of this matrix is equal to the first row should be the first column. 1, 4, 2. The second row should be the second column. 0, negative 1, 5. And the third column should be, rather the third row should be the third column. 3, 2, 0. That's it.